Hello everyone, once again I'm here thinking about what to do next. Or better, I know what to do next, but I don't know how and why and how and way more than that. So yeah, it's a journey that may take more than I thought. But anyways, Lucal is here once again in this new day that is not a casual event as it happened before that I stream on Thursday. Instead, it will be the usual going forward. And at times, once again, it may change in case of need. And what do we do today? Well, we pick up from what we left, from where we left off last week. Last week, after quite the struggle, maybe we can say that we managed to complete the step 1, the initialization of the control plane node, which I already know that I will need to redo once again. But it was important to do it as, let's say, an atomic step to properly understand how to do it. Now we need to go forward with the step number 2, and that is the CNI, which is a little bit of it's not a mess, but it's there are various choices, or better, there are various options that base themselves upon the needs, but I'm not exactly sure what my needs are. I'm not exactly sure if I can clarify my needs and pinpoint a specific CNI that will suit those needs. So we need to do some little bit of research, and that is the first step going forward. So apply the CNI plugin of your choice. And we must do this right now. I cannot go forward, or better, I already did execute some commands like this one to see that the control plane was correctly initialized, and because I was happy, to be honest, to have completed the first step. Now we need to go on with number 2, and following these instructions leads here. Installing a pod network add-on. Let's start reading about it, and then we'll try to understand what CNI we might start using for the time being, and then maybe we may change it down the line. We never know. Okay, caution. This section contains important information about networking setup and deployment order. And networking is not my strongest suit. Read all of this advice carefully before proceeding. That's the plan. I don't plan on trying to start something when I don't even know what to do, to be honest. You must deploy a container network interface, CNI, based pod network add-on so that your pods can communicate with each other. Cluster DNS, core DNS, will not start up before a network is installed. I guess because there is no network currently. take care that your pod network must not overlap with any of the host networks. You are likely to see problems if there is any overlap. If you find a collision between your network plugin's preferred pod network and some of your host networks, you should think of a suitable seeder block to use instead. Then use that during kubeadm init with the flags minus minus pod minus network minus seeder, and as a replacement in your network plugins YAML. So this is kind of the reason why I already said that I will need to redeploy what we did during last week, which is not an issue. I already have everything mostly set up. I know I need to change a couple of things that didn't work last time, but I already figured out why. But the main reason is that in my kubeadm -config.yaml file, where there is the configuration of the cluster, I guess, of the control plane and everything that needs to be set up by kubeadm init, anything related to the CNI was not created yet. I took some ideas from the core with a K, core OS GitHub repo, and I want to thank again the person that created it, because it was helpful, very helpful. They use Calico as their CNI of choice, and I don't know if it is exactly what I need, if it can be useful for me using that, or I should use something else. I need to do some research, as I said previously. Moreover, I didn't want to just copy everything they did. I want to understand what I'm trying to do. And that's why it took longer, because if I just copy and paste something that someone else did, yeah, that's easy to do. It's easy to deploy a lot of things in that way, but I want to understand it, because if I kind of understand it, maybe not extremely in depth, but at least to some degree, it will be useful, and it will allow me to maybe troubleshoot things in an easier way than if I just throw things into a machine, into a VM or multiple VMs, and that's it. Okay, let's go forward. By default, kubeadm sets up your cluster to use and enforce use of role-based access control. Make sure that your pod network plugin supports role-based access control, and so do any manifests that you use to deploy. This last part of the phrase, and so do any manifest that you use to deploy. Okay, interesting. If you want to use IPv6, either dual stack or single stack IPv6 only networking for your cluster, make sure that your pod network plugin supports IPv6. IPv6 support was added to CNI in v0.6.0. Container network interface. Yeah, okay. It's not a CNI, it's a CNI plugin the one I need to pick. Okay. Let's go into CNI. I need to choose CNI plugin. This will create the network that will allow the pods to communicate with each others. And here we go. Yeah, we are on the same page. Several external projects provide Kubernetes pod networks using CNI, some of which also support network policy. See a list of add-ons that implement the Kubernetes networking model. Please refer to the installing add-ons page for a non-exhaustive list of networking add-ons supported by Kubernetes. You can install a pod network add-on with the following command on the control plane node or a node that has the kubeconfig credentials. kubectl apply -f for the file and the definition. Okay. Only a few CNI plugins support Windows, and I don't care about Windows. You can install only one pod network per cluster. That's totally fine. Once a pod network has been installed, you can confirm that it is working by checking that the CoreDNS pod is running in the output of kubectl get pods --all -namespaces. And once the CoreDNS pod is up and running, you can continue by joining your nodes. If your network is not working or CoreDNS is not in the running state, check out the troubleshooting guide for kubeadm. Just for confirmation. Sorry. Let's check the status of CoreDNS currently. So SSH and if I go like this, yes, get pods. -a maybe? No, I wish. All namespaces. I have everything running, though CoreDNS is running. Let's check the list. Maybe we will find that something. Not this. No. Okay. I didn't do step 2. I only did step 1. So it's odd. CNI provides integrated container networking and network support with Cisco ACI. Not really anything. Yeah, Calico, there it is. So I was correct in saying that. Cilium is something that I'm slightly acquainted with. Canal, United Flannel, and Calico provide networking and network policy. CNI Genie, Contiv, Contral, Flannel, Gateway API, Knitter, Kube Router, Multus, OVN Kubernetes, Nodus, NSXT, Nuage, Romana, Spiderpool, Terway, and WeaveNet. Interesting. Interesting, but even though I have the names, I have no freaking idea which one to use. Anyways, I know I will not use ACI because I don't have anything to do with the Cisco stuff, therefore I don't need it. That seems to be a good reasoning, at least for that specific one. Here there is a list of plugins, including CNI plugins. Perfect. Antrea operates at layer 3, 4, so what is it, TCP/IP, if I recall correctly, to provide networking and security services for Kubernetes, leveraging Open vSwitch as the networking data plane. Antrea is a CNCF project at the sandbox level. What is it? CNCF is cloud native something, I don't remember, but it's not software foundation, but I don't remember exactly what it is. Anyways, I don't think I might use this one, but I don't have any reason to say no to this one currently. The only possible choice is that sandbox level for the cloud native projects is usually meaning that is not yet well graduated as this one, and it means that is not I don't want to say it's not great, but not stable, maybe not really. But anyways, this is the only basis of this current idea of saying no to this one, to Antrea. I would need a better understanding of what it allows it and what doesn't. But anyways, Calico is a networking and network policy provider. Calico supports a flexible set of networking options, so you can choose the most efficient option for your situation, including non-overlay and overlay networks, with or without BGP. Calico uses the same engine to enforce network policy for hosts, pods, and, if using Istio and Envoy, applications at the service mesh layer. Okay. Okay. So Calico seems to be a little bit more flexible in what it allows to do. It allows one to do within the cluster. But yeah, I have no idea. Canal unites Flannel and Calico, providing networking and network policy. Very limited description, but As it says, it unites Flannel and Calico. Calico we already seen. Flannel is an overlay network provider that can be used with Kubernetes. Thank you. It is saying a lot, it seems. Anyways, Cilium is a networking, observability, and security solution with an eBPF-based data plane. This part is freaking cool. I read a little bit about eBPF and how it was created. It's mindless, but really cool actually. I remember the interview to I think it was a Russian guy, but I don't remember exactly. And it was like, yeah, to ensure that it would be merged into the kernel, I had to rewrite the whole implementation and make it worse. He said something along the line of this. And it was really funny, actually, because it was like, yeah, you guys want me to work with you, but you want me to write shit. That's like how I felt it was, and it was really, really, really funny. But apart from that, yeah, that's really actually cool that there is an implementation that includes eBPF-based data plane. We will see. Cilium provides a simple flat layer 3 network with the ability to span multiple clusters in either a native routing or overlay encapsulation mode, and can enforce network policies on level 3, level 7, using an identity-based security model that is decoupled from network addressing. Cilium can act as a replacement for Kube proxy. It also offers additional opt-in observability and security features. And Cilium is a CNCF project at the graduated level. Part of the graduated level that is cool, but I mean, it's okay. eBPF is really cool for what I know about it. But I'm not a networking guy, so it's difficult to decide. I don't know what to base my decision on. And these are basic descriptions that are not giving a comparison. They are not, how to say, they're not giving me a table with the list of plugins. And yeah, this will allow you to do this list of things. This other one, it will allow more, less, a few more, but a couple that it doesn't. This one, for example, can also replace Kube proxy, which would mean that I can somehow configure the deployment of Kubernetes with Kube ADM to not have a Kube proxy, because currently I do have a Kube proxy installed. Okay. And to be honest, that used to be an idea I had previously when I tried, before I started streaming maybe, or after I started streaming, but it didn't end well, that little project I had. And it was, now that I think about it, it wasn't even on Fedora CoreOS, so it was easier on one side. But anyways, let's move on. CNI Genie enables Kubernetes to seamlessly connect to a choice of CNI plugins, such as Calico, Canal, Flanner, or Weave. CNI Genie is a CNCF project at the sandbox level. This is odd, but basically CNI Genie sounds like a layer So it is the CNI used by Kubernetes, but it's not an actual CNI. It is a translation layer, kind of. Let's name it like this. It's not probably the best way to describe it. A translation layer that connects to Canal, Calico, Flannel, or Weave, but it is or. It doesn't sound like that they can be used at the same time. Or maybe they can. Not sure. What else? Contiv provides configurable networking, native L3 using BGP, overlay using VXLAN, classic L2 and Cisco SDN ACI for various use cases and a rich policy framework. Contiv project is fully open sourced. The installer provides both kubeadm and non-kubeadm based installation options. This is a nice part because I'm using kubeadm. This is not a part I care about, but maybe this, yes. Contrail, based on tungsten fabric, which I guess was an older version or something like that, is an open source multi-cloud network virtualization and policy management platform. Contrail and tungsten fabric are integrated with orchestration systems such as Kubernetes, OpenShift, OpenStack, and Mesos, and provide isolation modes for virtual machines, containers, pods, and bare metal workloads. This sounds like a monster. What I mean is that it sounds like it's very well structured, given it can work with not only Kubernetes but also other implementation of Kubernetes, I guess. OpenShift, OpenStack, and such. Mesos, I think I've heard about it a few months ago, but just a little bit. Only the name, basically. And I may be mistaken with some other name that is maybe similar. I don't know. It's interesting, but I don't think I need that level of integration possibility, because I will be using just Kubernetes on one side. And on the other side, it is not just for the Kubernetes environment. It seems to be from virtual machine, actually from bare metal to pods and everything in between, which is not exactly what I need or what I care to do. Therefore, maybe Contrail is not the best choice. Flannel, we saw it previously, is an overlay network provider that can be used with Kubernetes, saying a lot and nothing at the same time. Basically, if you just wrote the name, it's the same as writing this phrase, to be honest. But anyways, maybe it's my networking knowledge that is too lacking, I guess, that lead me to believe this phrase is just saying, yes, Flannel can be used with Kubernetes. Thank you. But it says it's an overlay network provider. So, okay. Gateway API is an open source project managed by the SIG network, which I'm not too sure if I remember what it is. SIG network community, and provides an expressive, extensible, and role-oriented API for modeling service networking. Nice. nice, but at the same time, yeah, good. I have no idea. Knitter is a plugin to support multiple network interfaces in a Kubernetes pod. Kube Router is an open source turnkey solution for Kubernetes networking with the aim to provide operational simplicity and high performance. It leverages the Kubernetes API, BGP, and Golang for the control path, and Linux networking primitives, IPVs, IPVS, NF-tables, etc. for the data path. It provides a low overhead alternative, and it is used both in both K0s and K3s, both of which I had a small, not really small, but K0s definitely a small experience with. K3s a little bit more in depth, but at the same time not as in depth as I've been working on my own K8s cluster. Multus, I've heard about Multus, but I don't remember how. In which context? I mean, surely in this context, but Multus is a multi-plugin for multiple network support in Kubernetes to support all CNI plugins. Sounds like Contrail? No, CNI Genie. Egicalicus, Ilium, Contiv, Flannel, in addition to SRIOV, DPDK, OVS DPDK, and VPP-based workloads in Kubernetes. Given I don't know what these are, it may mean I don't need them, but maybe down the line I will find out I do need them. I don't know. This is a no for the time being. Like CNI Genie, by the way. OVN Kubernetes is a networking provider for Kubernetes based on the OVN, Open Virtual Network. A virtual networking implementation that came out of the Open vSwitch OVS project. OVN Kubernetes provides an overlay-based networking implementation for Kubernetes, including an OVS-based implementation of load balancing and network policy. Nice. No idea. Nodus is an OVM-based, like OVN Kubernetes, CNI controller plugin to provide cloud-native based services function chaining, SVC. Another case that, given I don't know if I need this, and I don't know that I need this, Nodus is off the list for the time being. NSXT, container plugin, NCP. Okay, thank you. So it will be NSXTCP, basically. Great naming. Provides integration between VMware NSXT and container orchestrators such as Kubernetes, as well as integration between NSXT and container-based CAS/PaaS platform, such as Pivotal, I don't know, container services, PKS, and OpenShift. Once again, I don't exactly need that. Given I don't exactly need that, it means I don't care about it. Goodbye. Nuage is an SDN platform that provides policy-based networking between Kubernetes pods and non-Kubernetes environment with visibility and security monitoring. I plan to put everything in my cluster. Therefore, the only thing don't, but it doesn't make sense to put it in a cluster, is the storage. The cluster will interact with the storage in its way, but it's not part of the Kubernetes configuration, I guess. I'm not sure how to say it. Basically, I have a NAS, and everything will go in the NAS. That's what I'm saying. Romana is a layer 3 networking solution for pod networks that also support the network policy API. This is nice. We had it before, something about the network policy. Yeah. No, in here, I guess. I don't remember. Spider Pool is an underlay and RDMA networking solution for Kubernetes. Spider Pool is supported on bare metal, virtual machines, and public cloud environments. Okay. Terway is a suite of CNI plugins based on Alibaba Cloud's VPC and ECS network products. It provides native VPC networking and network policies in Alibaba Cloud environments. I'm not in an Alibaba Cloud environment, so goodbye. WeaveNet provides networking and network policy. We'll carry on working on both sides of a network partition and does not require an external database. Nice. It just makes me think that maybe all the other require an external database, but I have no idea. So far, the one that gives me more seems to be Cilium. And this is actually the page for Cilium. And I will need to understand how to deploy Cilium on Fedora CoreOS. Cilium is a networking observability and security solution within everything. Okay. Cilium implements distributed load balancing for traffic between pods and to external services, and is able to fully replace Kube proxy using efficient hash tables in eBPF, allowing for almost unlimited scale. It also supports advanced functionality like integrated ingress and egress gateway, bandwidth management, and service mesh, and provides deep network and security visibility and monitoring. A new Linux kernel technology called eBPF is at the foundation of Cilium. It supports dynamic insertion of eBPF bytecode into the Linux kernel at various integration points such as network I/O, application sockets, and trace points to implement security, networking, and visibility logic. eBPF is highly efficient, and flexible. To learn more about eBPF, visit ebpf.io. Okay, let's go with Cilium, I guess. Stable release, development functionality overview. Service mesh, okay, getting started. Why Cilium? This is something that I might need to read. What is Cilium? What is Able? Introduction to Cilium. Why Cilium? Where is it? Why Cilium and Able? BPF is enable visibility into control over systems and application at granularity and efficiency that was not possible before, and that's why I like it. Okay, the shift. They did say that the BPF was at the base of Cilium. Nice. Nice. So it seems that Cilium is the one. And it seems that this page needs to be updated. Architecture and concepts. Maybe I can learn something installing Cilium. Okay, so orchestration systems. Cilium layer, live policy, repository, plugin, Cilium monitor, Cilium daemon, bytecode injection, BPF program, networking, container, kernel level. Okay. A deployment of Cilium and Hubble consists of the following components running in a cluster. Okay, so let's so the list as mentioned in the documentation is not extensive and complete, though there are various options for CNIs, some of which are specific for something I don't need. Those are rejected. The others could all be good, but Cilium seems to be the best, in my opinion. Given the little I know. Let's use Cilium. Maybe even replacing the Kube proxy with it. It seems fair. Okay, so a deployment of Cilium and Hubble, which I guess I need to install as well. Consists of the following components running in a cluster. Cilium agent. The Cilium agent runs on each node of the cluster, in the cluster. At I don't exactly know what my I at. At a high level, the agent accepts configuration via Kubernetes or APIs that describes networking, service load balancing, network policies, and visibility and monitoring requirements. The Cilium agent listens for events from orchestration systems such as Kubernetes to learn when containers or workloads are started and stopped. It manages the eBPF programs, which the Linux kernel uses to control all network access in and out of those containers. It includes, so agent is this debug client CLI. The Cilium debug CLI client is a command line tool that is installed along with the Cilium agent. It interacts with the REST API of the Cilium agent running on the same node. The debug CLI allows inspecting the the state and status of the local agent. It also provides tooling to directly access the eBPF maps to validate their state. The in-agent Cilium debug CLI client described here should not be confused with the Cilium command line tool for quick installing, managing and troubleshooting Cilium on Kubernetes clusters. That tool is typically installed remote from the cluster and uses Kube config information to access Cilium running the cluster via the Kubernetes API. Got it. I was confused a little bit there, but yeah, got it. What I mean is that I thought that this was the Cilium CLI, instead is a debug CLI, I guess. Operator. Is it a smooth operator? It's a Cilium operator, which is responsible for managing duties in a cluster, which should logically be handled once for the entire cluster, rather than once for each node in the cluster. The Cilium operator is not the critical path for any forwarding or networking policy decision. A cluster will generally continue to function if the operator is temporarily unavailable. However, depending on the configuration, failure in availability of the operator can lead to delays in IP address management, IPAM, and thus delay in scheduling of new workloads if the operator is required to allocate new IP addresses. Failure to update the KV store heartbeat key, which will lead agents to declare KV store unhealthiness, key value store, I guess, and restart. CNI plugin. The CNI plugin is invoked by Kubernetes when a pod is scheduled or terminated on a node. It interacts with the Cilium API of the node to trigger the necessary data path configuration to provide networking, load balancing, and network policies for the pod. Give me just a second. Okay, I'm back. Hubble. Do I need it? I don't know. Server. The Hubble server runs on each node and retrieves the eBPF-based visibility from Cilium. It is embedded into the Cilium agent in order to achieve high performance and low overhead. It offers a gRPC service to retrieve flow and Prometheus metrics. Sounds really nice. Relay, Hubble Relay, is a standalone component which is aware of all running Hubble servers and offers cluster-wide visibility by connecting to their respective gRPC APIs and providing an API that represents all servers in the cluster. Client CLI, the Hubble CLI, is a command line tool able to connect to either the gRPC API of Hubble Relay or the local server to retrieve flow events. And a GUI, the graphical user interface, utilizes relay-based visibility to provide a graphical service dependency and connectivity map. eBPF is a Linux kernel bytecode interpreter originally introduced to filter network packets, e.g. TCP dump and socket filters. It has since been extended with additional data structures such as hash tables and arrays, as well as additional actions to support packet mangling, forwarding, encapsulation, etc. An in-kernel verifier ensures that eBPF programs are safe to run, and a JIT compiler converts the bytecode to CPU architecture specific instructions for native execution efficiency. eBPF programs can be run at various hooking points in the kernel, such as for incoming and outgoing packets. Cilium is capable of probing the Linux kernel for available features and will automatically make use of more recent features as they are detected. And we have AI viewers, it seems. Yeah, nice. We don't have them anymore. For more detail on kernel version, see Linux kernel, of course. Data store. CNI requires a data store to propagate state between agents. It supports the following data stores: Kubernetes CRDs default. The default choice to store any data and propagate state is to use Kubernetes custom resource definitions, CRDs. CRDs are offered by Kubernetes for cluster components to represent configurations and state via Kubernetes resources. Key value store. All requirements for state storage and propagation can be met with Kubernetes CRDs as configured in the default configuration of Cilium. A key value store can optionally be used as an optimization to improve scalability of a cluster, as change notifications and storage requirements are more efficient with direct key value store usage. The currently supported key value store are etcd, and I have etcd already, but I plan to use this. Note, it is possible to leverage the etcd cluster of Kubernetes directly or to maintain a dedicated etcd cluster, which in my case, if I were to choose to use a key value store, I will go for the etcd cluster of the Kubernetes cluster. But anyways, these are the pieces. And in here, in here there are, oh Jesus, there are various things, but big but, there isn't K8s, K3s, generic, Okay, let's try to do this. K-test Cilium install. Okay, been in production, create the Kubernetes cluster with CNI. Okay, let's see. Let's see what it says. Control plane and data. Yeah. Node components. Kube proxy maintenance rules. Yeah, I want to replace that, but it's okay. Stop post name. Yeah, thank you. The system. Thank you. Configure Linux for Kubernetes. Thank you. Set up kernel modules for container networking. This may be needed. We can try to check that maybe. etc modules load d BRnet filter. Oh wait, this one I created this one. I think. But anyways, load these modules immediately. Overlay and BRnet filter. Nice. Create an overlay file system that allows whatever. Configure network parameters. Oh, jeepers. Mod grep overlay is already there. Disable swap. Store container D. Configure the system DC groups. Start and enable container D. Install Kubernetes components. Okay. Data repository. Install the stuff. Enable the stuff. HA proxy. Install Kubernetes control plane. And here we have a configuration that I can look into. I can compare it to the core OS with the K one that is used for Calico, but I guess some pieces are common. I see a lot of comments that may actually be really useful. Initialize the first control plane. Oh, look at that. It is exactly like mine. Okay, set up kubectl access. And where the hell is Cilium? Okay, these two should be done, at least I will do them after this stuff. Cilium on the cluster. Okay, Cilium install. What's the magic happen? Cilium status. Nice wait. Should see something like. Okay, disabled. Verify cluster, get nodes. Now your nodes should okay, get nodes. I have a single node and it is ready. Go figure. But yeah. Verify your cluster health. Oh, this one I get component statuses as deprecated. Okay. An older guide, I guess, but I can still use it. I have everything healthy, to be honest, so Go figure anyways. I will need also to try to search for the configuration of the replacement for Kube proxy. So basically I will need to, I know for a fact that I can say to Kube ADM to not bother installing Kube proxy on one side, but on the other side I need to configure everything so that Cesium will be doing the job of Kube proxy. So in the kubeadm -config.yaml I will need to add a lot of things, more than what is here, but let's read what is here and let's pick also our version. Okay, so we have init configuration, VB3, yeah, okay, node registration, specify CRI socket, CRI, CRI socket, that will be used in the KTS cluster, and I use CRI-O, so okay. Then cluster configuration, API version, cluster name, which is something that I didn't put, the load balancer address, control plane endpoint, that's totally already done. Support for IPv4, IPv6 dual stack. I don't plan on going on dual stack, to be honest, but networking, pod subnet, and service subnet, I guess will be created as well. Specify DNS domain for the cluster, cluster.local. So I have controller manager and I have etcd. Okay, API server, anonymous out true. Add any other API server arguments here. Controller manager configuration, node monitor period 5 seconds. I could add that maybe, I don't know. Scheduler configuration, I don't have any scheduler configuration. Any scheduler arguments here. Thank you, really useful. API version, okay. C group driver, definitely. Swap, failure swap. Yeah, probably this one I need to add it. Feature gates, node swap true. Memory swap, limited swap. This one I might add it as is. The rest of the stuff, let me take this one as well. Maybe I can, no, I can just do this. So, okay, cluster configuration, Kubernetes version, cluster name, control endpoint, certificates directory, okay. Image repository, time for control plane 4 minutes on API server. Okay, controller manager, DNS. Nothing about DNS in there. etcd, there was nothing, but I fixed it. Networking, DNS domain, okay. Service subnet, okay, and pod subnet. Scheduler, nothing. I don't know if it's needed at this point, to be honest. Okay, node registration, CRI socket, CRI-O sock. This is the one I will use. Ignore pre-flight errors. Kubernetes version, file existing on track. Unless I actually get the error, I don't plan on adding that. Okay, kind, Kubernetes configuration, okay. Failure swap, feature, memory swap, limited swap, yeah, it's exactly the same. Volume plugin, container runtime endpoint, also in here. Also in here. What the hell is it above? I read it before as well. There it is. On the init configuration, there is the key socket. And in here it is the container runtime endpoint, which I did not put in my version C group driver. Okay, so I think I can kind of mix these two. Those IP for the pod subnet and service subnet, I think I can change them. Okay, let's start to do one thing right away. This one needs to be moved in here, I guess, because you may recall that the other time I did not I did not find them enabled, and that's fair. I tried to enable them, but they don't exist yet. They are not technically installed until the reboot is completed, so it goes there. And I need to change with okay, packages. Are already stored, I guess. And I guess I need to add the version in here as well, which means 1.35 and 1.35, if I recall correctly. I can check, I guess. Kubernetes version, I guess. Yeah, perfect. So I'm sure that I'm installing the correct version all the time. I can reboot, then I have the stuff enabled. Yeah, I will do something that is ugly because I don't want to do the different files. If I guess then not in here. Well, I will need it in here as well, I guess. But it is in here that I will go if RPM. By the way, sudo RPM. It didn't give me issues so far, but I never know. Sudo RPM S3 install kubectl 1.35, I guess. Cube. Oh, come on. CTL. That's my version. Oh, come on. Version 135. Yeah. Fi. And fi. And in here we go like this. Sudo system CTL enable. In this case, this was now. Kubectl, I guess, dot service. System CTL status. To check the status, you do not need to use sudo. Tiny tidbit of tip. To change the status, you need to be, I guess, the root user. But to check the status, there is no status for kubectl. It just is. That's even better. Okay. So I need to populate the condition. The condition is that the how do I say it? Basically, the hostname include control, given that my machine are or control plane or worker. So if the hostname include the control, you do that. How do I do that? I don't want to use a grep. If host name yeah, there it is. Equal okay, so I don't want to go like that, but it seems I will need to if host name equal control includes something like this. Yeah, I do not consent. I wanna okay, if string includes string part of string thank you string oh, nice. That's really nice. So double, okay. I don't mind using double. Doesn't hurt. Okay, so in here, if I go like this, in theory, yep. And if I go like this, in theory, no. That's annoying. So in theory, I'm going to bet it works. So I expanded this shell script once again to perform the configurations that most likely I could do through systemd units altogether, but I don't think it's an ugly thing to do it like this. Not necessarily ugly, let's say. Okay, so This is the version for control plane initialization. Okay, so far so good. Now, and this one is instead, I don't know if I can put it in the same line, but this is for the load balance in the cluster somehow. What else? Okay, so I need to now add other stuff we were saying, and the other stuff we were saying, first of all we relieve that one, and we have this one, which includes an init configuration that I didn't have, that if I recall correctly is basically the same as the one in here. There are just the ignore preflaps, and I use Creo, not containerd, therefore I can copy this one and add it as is. I mentioned before that I did not copy and paste stuff without understanding, but this I understand. Just v1 beta 4, I guess, and I hope that it doesn't break the Chris socket configuration. CNI stuff. Okay. Then, cluster configuration. We need to add, well, honestly, let's add a cluster name, just because. Locally cluster. And let's hope that it's not pushed. Okay, this one I already have. Networking. The networking part is important. And we have a networking there as well. And they are the same. They're the same. And for that reason I will copy one. And it is part of the cluster configuration, so it goes in here. And we go in here, we go CNI stuff. And we remove the IPv6 stuff, because I don't care about it. And I don't know what to put there, so whatever. And same here, to be honest. Maybe in here I can check the environment. Was it? Cluster name here. Your cluster DNS name here. Hey, fuck's sake. Uses 12 as service subnet. An example could have been useful Template, I don't know, template. Yeah, template, fuck off. An example. Maybe in the readme. My cluster.myDomain. Huh. I don't know. I do not know. My cluster.myDomain. I used an IP up there. Not. Yes, let's go check the documentation, I guess. Once again. Duplicate. DNS domain. Thank you. DNS domain is the DNS domain used by Kubernetes services. Defaults to cluster.local. So if I use cluster.local, is there something else in here? Nope. Okay. Kubernetes DNS domain valid configurations. For cluster configuration. Cluster config. Must be it would be nice to have a freaking example. Example that is not cluster.local, maybe, just maybe. Cluster.local. Everybody uses cluster.local. What the fuck? Yeah, thank you. Give me a cluster.local. Yeah. I thought so. For fuck's sake. Oh, yeah. You know what cluster.local will do? Is the default. I don't necessarily need to change it. I feel like. Okay, this can be closed. This as well, because I can always go there. Same here. Okay, so default value by documentation. Not sure what to put in there. Okay. Init configuration already, and Kubernetes configuration. Yep. I need to add this part for sure. Swap stuff. And this one. CNI stuff maybe. This one is one that I don't exactly understand. Okay, now I need the Cedium part. Cedium to replace Kube proxy. Kube ATM. Kubernetes without Kube proxy. Let's see if I get it. Okay, depending on CRI implementation you're using, you may need to use the CRI socket flag on your Kubernetes init. For example, if you use Docker CRI socket. Yeah. Skip phase add-on. Yes. Okay, so okay. Okay. So, okay, but the skip phases. Okay, wait. Vediamo. Skip Kube proxy config file. Yeah, the code was useful. Thank you. I don't want to read the whole fucking code. Sorry. Yeah, but to be honest, I need to add it to the cube. Gbus. Yeah, but I want to add this to the fucking file. I don't know if it works, but that's what I want to do. Kube ADM -config and skip phase can coexist. Something like that. Okay, so I can add skip phases, I guess, for the init configuration. Give me a check. Where is the init configuration? v1 beta 4. Okay, once again, duplicate, skip phase, something like that, I guess. v1 beta 4. Skip phases, preflight. Oh, come on, are you serious? Oh, ignore. Okay, skip phases. In this case, it's in the local API endpoint, but it's okay. Skip phases is a list of phases to skip during command execution. The list of phases can be obtained with the kubeadm init help command. The flag take precedence over this field. Okay, but I will use the field, if you don't mind me. And it is part of init configuration, so it goes in here. Skip phases. And you said that if I go kubeadm init help. Oh wow. Okay, pre-flight certs kubeconfig etcd control plane kubelet config plus certs mark add-on. So add-on / kube proxy. I guess I go add-on / kube proxy. That is really similar to what I found. Let me think. In somewhere over the rainbow. Somewhere in here, because it's equal add-on / kube proxy, so it seems to be correct. Do not install kube proxy. Cilium will take its job. In my case, Cilium is the AI in my cluster. It's taking the job of someone else, I guess. Now, I started early. In theory, I have everything ready to enable to redeploy things, and I expected that some things will break. I do not have much time, therefore I think that I will end the stream here, and I will continue next week with the testing of this week configuration. Let me check the notes. I have fixed and improved the shell script to install and enable packages, I guess. Install packages and enable service. Okay, yeah, I don't care. I have included in the kubeadm config.yam file necessary changes to support the CNI of choice. It should work. Next week we'll test this and troubleshoot whatever does not work. If it goes well, we deploy Cilium as well, and the cluster will be mostly up and running. Okay, so this was good to a degree. And yeah, I took some notes about what happened, not only there, but in my trusted notes in here as well. And this was good because I understood quite a few things. I have many things that I don't understand yet, but I guess I will come to understand during the next weeks as I continue to implement the cluster, and soon I may actually start to deploy something in the cluster, and that will make me so happy, so happy. Oh, Jesus. Okay, done that, guys, everybody. Thank you for watching as usual, and see you next week. Luckily out. Bye.